just talked about the U substitution and how that's actually based on the chain rule, right? It's kind of weird because we have a product in many cases, and we think, okay, well, that's dealing with the product rule. But in fact, U substitution is actually based off of the chain rule, right? But there are cases where there are products in which the chain rule doesn't help us out, right? And so behind my huge head, we see the antiderivative of x times e to the x dx, right? If we consider that antiderivative for a second, will U substitution help us out as we're trying to determine what's going on here? Right? Well, if we make U equal to x, right, du is 1, that doesn't take care of the e to the x at all. If we were to make U equal to e to the x, the derivative of that, du, would be dx, e to the x dx rather, which again doesn't help get rid of the x. So U substitution isn't any good for us at all. Right? So where do we go with this? And the idea is, well, maybe we can antiderive based off of the product rule when all is said and done. Maybe that's something we actually can do. If we think about the product rule says if we're taking the derivative of two entities that are being multiplied, u times v, right? Well, we derive one term and we keep the other. So keep the u, keep the first term, derive the second, plus now we keep the second term and we derive the first. Okay. So how does that relate to this x times e to the x? And here's what we're actually going to do. We're looking for expressions that involve antiderivatives. So what if we take this equation involving the product rule, and let's modify it just slightly, just a bit. I'm going to just subtract v du from both sides, all right? And when I do that, I'm now looking at u dv equals the antiderivative, excuse me, not the antiderivative, I'm ahead of myself here, equals the derivative of uv minus v du. All right, so I just took this term right here and I just moved it over to the other side of the equation and I just rearranged the equation there. Okay, why am I doing that? Well, again, I want something with an antiderivative. So I'm going to actually take the antiderivative of this left side, okay, which I can do on an equation. And the reason why I'm doing that is because if I have this antiderivative of this expression, that lines me up with an antiderivative of this expression right here. So you see where we're going with this. So the antiderivative of u dv, but I can't just antiderive one side. Yeah, I got to antiderive both sides of my equation. All right, so my other side of the equation is a difference, and I know from my sum difference rule, my property there, that I can actually split that up into two antiderivatives. So I can antiderive both of those parts as well. Okay. So what does all that mean? I'm getting low on space here, so I'm actually going to go right up here. So just ignore this for a second because we're not going to hit that until a future problem. But the antiderivative of u dv, that actually, we can't do anything with that right now, but that's okay. We don't want to do anything with that because that's what our setup is going to start with. All right. What's it equal to? Well, look at this. We're taking the antiderivative of the derivative of u times v. Well, what happens when we take the antiderivative of the derivative? Yeah, they're going to eliminate each other, and all we're left with is just uv. Right? And then we have our subtraction, and then we have our other antiderivative, which is v du. Right? So part of you saying, okay, great, what does all this mean? Well, what it means is that we can actually take an expression like this one right here where we can't use u substitution, and we can kind of do an antiderivative based on the product rule, where our antiderivative will actually be another expression which involves subtraction and an additional antiderivative, or a second antiderivative, not an additional one, because this, again, is matching with that. So what ends up happening is we have this as our answer. All right, so we have an antiderivative that involves an antiderivative, okay? But hopefully, this antiderivative is one which we can actually find. That's the idea behind antidifferentiation by parts. You take an expression, an antiderivative expression which you cannot antiderive, and you rewrite it, all right? You work on it through parts. You break it up by parts into something that is easy to find and an easier antiderivative to solve. And if we can do that, we can get our answer. What does it mean ultimately? It's one of those situations where we're going to start off with a very simple expression, and our answer might be quite long. Okay, but if we derive that answer, it'll end up being equal to that expression right there. So more to come in the next video where we start looking at examples.